I know why people who practice DDD say that you need to implement persistence patterns such as repository, unit of work, specification. I know you need to separate the persistence from domain and application. That's fine. I know what they mean when they say that EF Core is built on the principles of DDD. But what I don't understand is how those people who know all that then decide to embark on an incredibly complicated and costly adventure of building an entire abstraction layer around EF Core and persistence. I don't understand that. What's the point? To please the gods of DDD? What? I know DDD is much simpler than that, and I will show you that in this demo. And if you stay with me till the very end, you will say at the end, yes, this is the DDD I want to have. So let me show you the code. Take a look at this minimal API endpoint implementation. It uses a DbContext to isolate an aggregate, a single aggregate, then does what it does to that aggregate, and then saves changes after utilizing the aggregate instance in this command. The technical problem is that this implementation depends on DbContext. A similar but much worse situation is the query endpoint. Query is using link to entities as a specification. Specification is a mandatory part of DDD. But there is a substantial reason to frown upon using link to entities directly in the applicative code. Now, the application depends on nuances of EF Core. On top of that, this query endpoint also depends directly on DbContext. So we need to do something to isolate the applicative layer from EF Core. This is the DbContext. It is surprisingly clean now that you saw how complex the code is that uses it. However, this is where my views start to differ from those of many DDD practitioners. I will say that dbset is the repository I'm looking for. I will say that a link to entities is the specification I need, and the DbContext is the unit of work I want to have. This is precisely the moment when many developers choose to introduce wrapping classes to separate the application from EF Core. I will only use interfaces and use the DbContext, which is already there as the concrete implementation. So the ride down the DDD rabbit hole begins with this line of code, a simple declaration of the repository interface. A repository would return a single DDD aggregate, also using a strongly typed key, which is a typical pattern in DDD projects. Now, the only way to fetch an aggregate in DDD is by its key, and you would only capture one or load one aggregate from the database. That includes all the entities and values within that aggregate. We can also add an aggregate. We might need to update the aggregate, but now this is where I say no. We are not writing an absolute clean, universal repository abstraction. No, it's going to be EF Core underneath forever. So I will remove update because I know that my persistence layer is tracking changes and it will do that for me. The basic objection I have to DDD purity is that you just don't need it. Beyond certain point, you just don't need it. I will keep my abstractions opinionated and I will let them lean towards EF Core. Another example is delete. DbContext requires an entity to mark it as deleted in change tracker. Repo users might expect a convenient delete method by key, which is not supported by DbContext directly. However, I can implement it combining try, find, and delete. I see no justification to go any further in generalizing repositories for EF Core. So we get to the unit of work interface. I will follow similar thinking here. Unit of work has two responsibilities. One is to locate and organize repository instances used within one transaction. The other is to manage a transaction via committing or rollbacking it. But again, DbContext does it in its own way, using optimistic locking and short-lived transactions. Would it make sense to make it disposable? No, there's no need for that either, because we supply DbContext via dependency injection, and the IOC container will dispose of it anyway. What EF Core does is to let us save changes. I will go to such length as to saying that the save changes async should return integer as the number of rows affected, and it should also accept the cancellation token, because that is the signature of the concrete method on DbContext. These two opinionated abstractions are all we need to remove direct dependency on DbContext. Instead of DbContext, accept abstract unit of work. Instead of accessing a DB set directly, request the repository, save changes on abstract unit of work. The result is that reference to EF Core is not required anymore. The endpoint implementation is now independent of EF Core. That made it testable in isolation, and it is now persistence ignorant, with just a little bit of opinion built into the abstractions. Now, this reminds me of an earlier video I made in which I said very plainly, you don't need a service layer in every minimal API application. Look at this endpoint implementation. It is implementing one endpoint, one command in a minimal API application. Do you need a service layer here? Obviously not. The only thing a service layer would do in this implementation is to separate from HTTP, which is not really a big deal, because you would have to introduce an entire layer of abstract results and then the mapping to HTTP responses. So you would have to write that code, to test that code, cover it with all kinds of tests, test what mappings you are missing, what data is lost in the process, everything. For what purpose? There's no purpose in that. The most obvious deficiency of previous implementation was that it was tightly bound to EF Core, so you couldn't test it in isolation. Now that I just inserted thin layer of interfaces, that deficiency is dismissed. You can test this and check those HTTP responses and see if the response has everything it should have. You can write all the tests you wanted. This is the service. And the same way as I'm simplifying the layer that wraps around EF Core, I'm also simplifying the layer that implements applicative logic in my minimal API application. You can agree with that or disagree. I really don't care. I prefer to keep my code simple. Let's continue. I will now give you a very lightweight implementation of unit of work and repo interfaces on top of DbContext. But before that, I must steal a moment of your time to remind you that this channel and all the content on this channel is free, but only thanks to the financial support from my patrons. If you want to support this channel and help me maintain it and keep it free forever, then please join me on Patreon and give a support to the channel together with other patrons there. That will give you access to the source code of this video and all other videos on this channel. It will give you access to some discounts and other goodies that are not available on YouTube alone. Thank you very much. Now, seriously, let's get back to code. Because DbContext is a unit of work and DB sets it exposes are repositories, I will implement the repository by simple indirection. All repositories share the same method names, so I will opt for the explicit implementation of the interface to solve method name collisions. And then it begins. Finding an aggregate means to access the root entity and include all other entities in that aggregate. Then use a link to filter the entity by key, and this is DDD style find implemented as a simple method on DbContext. Adding an invoice just delegates to dbset, and so does delete. 4 lines of code that just change the interface, but do not change how DbContext works. Another repository, another 4 lines of code. And how do we represent DbContext as abstract unit of work? Oh, it's even easier. Getting the repository is trivial. This object is the repository. An attempt to fetch a repo for an entity that is not the aggregate root will throw at runtime, so there will be no harm done. You can only use this method right. And what about saving changes? Well, nothing. DbContext already has that method. The implementation is complete. The unit of work is 1 line of code. And if you fear that this DbContext class is growing too large, with support for many aggregates, then just make it partial, then pull each concrete interface into its own partial class implementation. That's 4 lines of code per aggregate. And the main DbContext implementation will remain small and clean. And that is all you need to support all commands in the project. All commands will look the same and stay independent of EF Core. Querying is different. Every query is different. It will do whatever it takes to get the result. It will cross aggregate boundaries. That may look like a problem, but that's the reality. That's what queries are. And it's really not a problem, because querying is built into EF Core. EF Core supports CQRS natively. And that brings the question of specification back. I see it as a misunderstanding that programmers believe they need an abstract specification around the link to entities. They don't. DDD also doesn't really say that you need a specification. DDD is not about that. DDD says it needs decoupling and it needs clarity. There are at least 2 ways to add clarity to this. One is to implement that heavyweight specification, abstract, clean specification that doesn't know about EF Core or anything. The other way is to just put this into a method and give it a name. Both are clear, so opt for the simpler variant. Let me show you. Define an interface and put the data definition there, give query a name, give it parameters with the names that are telling, and that's it. Then provide a complete implementation in a class that depends on DbContext. The sheer complexity of this query warrants it a place in a dedicated class, but please observe, this class is located in the infrastructure layer. The domain doesn't know it exists, and yet it is there and it does things in the best way possible for EF Core that will execute this. That will immediately simplify the query endpoint implementation. First, no need to have query types here. DTO is defined where the query is defined. Request query interface this endpoint needs. Then do what the endpoint does. For example, make calculations that depend on server time. Even here it could be dubious to depend on server time, so you might want to inject some time server as the parameter. That would help make it testable again. Anyway, that's another story. Just pass the parameters to the query and only transform results if needed. Most importantly, remove dependency on EF Core, and for every query in Minimal API, the code will look like this. Prepare the parameters, invoke the named query. It only remains to register dependencies in the program.cs, register the unit of work, register the queries, and you are done. And that is everything. What else could you wish for? Did I implement the repository pattern? No, of course not. Did I implement the unit of work pattern? No. Did I implement specification? Oh, no, I would never do that. Yet I have all done. But there is an important detail My interfaces were a little bit opinionated, just as much as required to make all this with almost no code. Is this the DDD you want to have, or you want it the hard way? It's up to you.